we'll be looking at complex numbers again, this time with a kind of a twist. It's kind of fun because you can make circles in complex number planes in a kind of a different way. It's rather novel and useful later on. All right, so here is a circle, and you see that it has a radius of 3, and it has z right here, although z is actually anywhere on the rim of the circle. Anywhere you can draw a point there, as long as it's 3 from the midpoint of the circle, then it fulfills the conditions that we need for this circle. So let's go ahead and define some things really quickly here. What we mean when we say that we're going to make a circle for it, the absolute value of the complex number that can be anywhere on the circle, okay, on the edge, is going to be the distance from the midpoint of the circle, in this case, 3. All right. Now, not all circles are going to be in the middle of the graph like this one. Sometimes they're going to be off over on the right coordinate, sometimes off on the left, or up and down, whatever. So first, let's just make sure that we understand what we mean by the absolute value before we move the circle around. So I'm going to make the circle bigger. There we go. Now the absolute value is 4. And you see the difference there? It's nothing else has changed but the absolute value. The circle just got bigger. And z can be anywhere on the circle. All right. Now, let's move the circle up. We'll take the midpoint and just go up the imaginary number line. Now watch what happens. There you go. We moved up this many points, okay, 1, 2, 3 points, and it's on the imaginary number line, so the midpoint is right there, okay? And that's what we're taking away. We're taking away the midpoint, all right? Otherwise, the conditions were the same. We still have our absolute value of 4, so it's still the same radius. Okay, let's expand on this. Let's move it again. There we go. So what do you think, knowing what you know now, will be right there? It's still negative. We're still taking away something, but we're taking away something a bit more complex. Obviously, we're still going to have some imaginary components. Let's take a look at there. Where are we? Well, we're 4 there and we're 4 there. So there you go. We're going to be taking away a complex number called 4 plus 4i, and that is the middle of the circle, okay? So let's move it some more. Let's have a little fun. We're going to go down this time, and the midpoint will be right on just the real number line part. So now the only thing we have for the midpoint is going to be a real number. So that's what we're going to be taking away. So z minus 4 is going to be equal to 4. That gives us the midpoint of the circle. The absolute value, 4, gives us the radius, and z is anywhere on the edge as it's spinning around. Okay. Let's move it again, this time over on the left side. Here we go. It's the same circle, it's been moved. The midpoint has moved 2. Now, see if you can guess it in just the second or two. Where are we? Okay, it's the real number line there, and it looks like a -3 there. So we'll be taking away a -3. But we usually like to simplify things. So taking away a negative, we wouldn't normally leave something like that. We'd go ahead and clean it up to a positive. Now this is where students can quite often get confused until they have it in their head that, when I have a number, complex number z, and I take away something, that's going to be the midpoint. So if it's positive, I'm taking away a negative. So just remember that, and then you won't get as lost. Because it can be real easy to lose track of the plus and minus and where you're supposed to put the middle of the circle. Let's move it again. This time it's going to be over and down, but I think you'll be able to catch on really quick now. Because see, I put a negative there. So what are the coordinates that we're going to be looking at? Obviously -2 and -1i. And there it is. Okay. Now, since it's -2 and -i, we're going to change that to plus 2 plus I. Okay, so it's really not that bad, and it's kind of fun that you can do it this way. If only the circle equations were as easy in the normal Cartesian formulas. But all right, Hope that helps. Hope you understood it, and I'll see you next time.